Hey, I hope everybody's having a good evening. Here's Venus. That's the only thing to look at tonight, so there you go. 500 degrees there of crushing pressure and heat, so kind of a far cry from what we had today. In fact, it was kind of a cool night here. I shot this about 3 in the morning last night, showing we were down in the lower 50s today. And there's some parts of the country that got a lot cooler. Let me see if I can pull it up real quick. I'm going to go to my list of sites here. I kind of like going and getting just random stuff. And we'll go to the official plot of low temperatures this morning. This is direct from the Weather Service, from NOAA. There you go, lots of 40s there across the central U.S. In fact, it looks like the coldest spot right there is Norfolk, Nebraska, there at 37. And here's the 35, just north of Kearney. I don't know those towns too well. So it's just north of the Platte River there. So we're starting to get close to winter, and I'm pretty sure we're going to be looking at the first freeze here in the next couple of weeks in the lower 48. So let's see here. Current weather. Clear skies here in Texas. You see the telltale sign of high pressure. All these plots here showing calm winds, all the way from Houston up to Oklahoma City and all the way back to east to Jackson, Mississippi. And temperatures are mostly in the 70s. And we'll take a quick look out west. It seems to be becoming a habit, but I'm always curious what's going on out in California, because our weather comes from that direction, obviously. Looks like a little bit of moderation of the temperatures, not upper 90s like we saw a couple of days ago, but there are a few lower 90s and 80s. The flow looks a little bit less monsoonal. There's probably a little bit of south flow through here, but otherwise it's just kind of chaotic. Looks like maybe kind of a heat low out in this area here. So for our big setup, one thing I've been doing is showing you the streamline analysis. This is what it looks like for today. And you see that little low pressure, that barotropic high we had over the eastern U.S., now over Kentucky. And as it drifts south, that brings this cool easterly flow across the Great Lakes into the central U.S. That's one reason it's so cool in this area. It's cold and dry. Further out west, though, we see kind of a combination of heat lows and barotropic or baroclinic lows up in Montana. And behind that, some cool polar air off the Pacific. So that's kind of the large-scale pattern. And one thing that we would like to look at here is the thickness charts. We haven't really done that in a while. So thickness is kind of like the average isotherm from about, it's kind of like averaging the temperatures from around sea level up to 18,000 feet, or about 5 kilometers. And what we, hang on, let me check my monitor windows so I can make sure you can see all this. Okay, you see that tight packing of thickness lines right here. Thickness is going to be these red and blue lines here. And you see they're very tightly packed up here in Canada. So this indicates a frontal zone. This is a baroclinic area, potentially baroclinic. And we look at the warm side of that gradient to find the fronts. So that's pretty easy. You just drop down here, south of these very strong gradients, and you try to drop them in the troughs, like you see here. Because fronts, by definition, they will lie in pressure troughs. So let me just draw that very quickly. So the main frontal action is way out there in the Pacific, and maybe one little front way out here in the Maritimes and out there offshore quite a ways. Now we do have this system here in the central U.S., and I do see some gradients. But the question is, do we have temperature advection? Because that's where we actually have the front. Or that's where we actually have an active front, I should say. I think you could probably make a case for a weak front maybe here, Washington, D.C. up to Scranton, back down to Roanoke. It's kind of hard to tell, but you can see this. I'm going to take a look at the thickness chart, see if I can pin that down, see if there's any evidence of a front. That'll give us something different to look at, definitely. So let me pan our surface plots here from last hour. And yeah, I can kind of see maybe a little bit of frontal action in Virginia, maybe a very small mesoscale front. Maybe something like that. And you do have about 10 degrees of temperature difference across that. So, you know, that'll support some frontogenic, some baroclinicity in this area. See the convergence there of the winds. Further back west, it looks like we have a little bit more like high pressure. And when you have high pressure, you tend to diverge the wind field, and that spreads apart your temperature contrasts. So that tends to lead to frontalysis. And the big question is, what's going on out in the Caribbean? Got Hurricane Matthew here. Got the 8 p.m. advisory here. Do we have winds on that? Yeah, wow, they got a maximum sustained winds of 150 miles an hour. So this thing really picked up very quickly. Switch over to the satellite. Here we go. This uses the NHC temperature enhancement scheme. We can kind of run that forward, and you can see that's about 80 miles off the coast of Venezuela. So that's about right here. And there's the eye, and here we got the eye wall right there. And one thing that we look for to monitor the trends is the cold temperatures. We look for expansion of that and cooling. And we definitely do see that. We see a little bit of expansion of this very cool cloud top area, and a couple of new towers coming together here. These are new cumulonimbus towers, and that feeds latent heat into the storm. So this storm is definitely intensifying, and yesterday we didn't have that eye that we do today. So going strictly off satellite, let me shrink this window so you can see what I'm doing here. See, we got a latitude, longitude readout at the bottom. So we can take a quick sample of the center on the storm, and we've got 13.45 north by 71.9 west. So that should fall within maybe about 10 to 15 miles of the NHC track. And it's kind of good to pin that down because you can use that to get an idea whether your forecast models are on track. So let's switch over to that real quick. These are what the tracks are looking like for Hurricane Matthew from the deterministic models, mostly the global models here. And you probably remember yesterday we were having a couple of models, including the UK Met and European. They were tracking this storm over Haiti over the next few days. Well, they've backed away from that. And we're going more, it looks like, with a more westward track, bringing it into eastern Cuba, possibly across Jamaica. Now, the strongest of these models, from what I saw, was probably the GFDL model. And that's a very sophisticated model that was developed back in the 70s as an experimental research model. And finally, around the 80s, they started using that operationally. And the main strength with that is it has a very strong modeling between the atmosphere and the ocean. So a lot of the sea surface contrast and even the temperatures down below the ocean, it integrates that into the model. When you have, for example, convergence of the basically the hurricane, when it's over these ocean waters, it has an effect on the ocean beneath it, and this model is able to handle that pretty well and depict some of those processes there. So we tend to see very strong skill with the GFDL. Now, surprisingly, the GFS has also been doing pretty well there. And that would probably, let's see, where is that? Yeah, that would be this track right here. right in the middle of this green track. So it looks like our solution is going to kind of lie between that and the GFDL. And that's going to bring that over the Bahamas, most likely towards Freeport. And depending on how much air there is, that could take it all the way into Miami. So that's going to be several days away still. So we're looking at, let's see here, October 5th. That's going to be about Wednesday, I think. Let me check the calendar. Yeah, the 5th is Wednesday. Same solution at Canadian Meteorological Center. So we're looking at midweek for Florida to be under the gun there. And we are approaching a very important change here in the behavior of Matthew when the recurvature is actually going to start. So that's a big unknown in itself. And we're seeing the model tracking, or we're seeing the hurricane tracking a little bit south of these models. Let me show you the point, the location exactly where it is, and that's going to be right here. So already we're still tracking a little bit south of the model solutions, and we were seeing that yesterday too. So that's going to favor the most westward tracks there. So if anything, that raises the odds for Miami a little bit, but you know, that's still a ways off there. All right, let's see here. I'm going to look at the official track. They're bringing that pretty far east. And let's look at the intensity. Where's that? I'm trying to remember where they keep the wind forecasts. I've been looking at way too many other products here. Okay, those are just probabilities. Well, guys, I can't remember exactly where they keep them, but I'm sure you can look that stuff up yourself at the nhc.noaa.gov website. But I was looking at the model forecasts of intensities, and they were putting it mostly in the Category 3 range, with another peak as it comes out across Cuba on the north side, back up to Category 3 mostly. There were a few outliers up to Category 4, and one or two of the statistical models had it up in Category 5. So that kind of gives you an idea of what we're looking at on that spectrum. So let's go back to the forecasts, if I can get over there. Okay, back to the GFS. We'll check out the weather here in the North American area. So I'm going to take you forward to tomorrow. Got that low pressure area out on the Great Lakes right there, continuing to spin, not really doing anything. And with that backside cold air advection from the north, that's going to keep the moisture offshore for the most part. Then over the weekend, things stay pretty fair across much of the U.S. there. We start to get a little bit of a return flow off the Gulf, starting in West Texas, and then starting to work up I-35 around Monday or Tuesday. So that's going to start bringing the moisture north. And then we see the approach of the hurricane. GFS has it grazing Miami there. This looks to be maybe about 60 miles off the coast. But here we are splitting hairs. This is quite a ways off. This is Wednesday, 18Z at, let's see, this is 120 hours out. Then we have another surface system going up through the Dakotas, up to Quebec. And on the back side of that, we do get another shot of cool air coming into the plains right there. So another front on its way down later in the week. And we should see a cool down as next weekend approaches. And then we've got the GFS here grazing Wilmington off the coast of Charleston too, to the Outer Banks of North Carolina. Could be something to watch there for sure. But further out west, a lot of cool air advection working in the backside of that system. So it looks like temperatures will be below normal for the first half of, at least the first third of October. And then you can see out by next weekend on Sunday, bringing the remains of Matthew across possibly Maine. And the rest of the model output just looks cool. High pressure across the U.S. Very calm weather. Looks like another Pacific system working in towards the Seattle area. And pretty good return of moisture there into the southern plains, but we are getting pretty far out there, October 15th or so. Okay, let's see. One other cool thing I did want to show you before I leave. I was looking at the model output on this Meteor Center site. I'll show you the URL right there. I set this up to where we could look at all the models at a specific time. I picked Thursday next week, Thursday morning at 12Z. And I'm going to show you all the different possible solutions from different models. So we're going to start with, let's see here. Okay, we're going to start with the GFS from the Weather Service. And you can read that right down here at the bottom. Let me see if I can move that a little bit. So just read that off at the bottom if you're kind of confused about what I'm covering. But there's the GFS for Thursday morning. So at that specific snapshot time, it's showing Matthew right off the coast of Daytona Beach right there. And then we've got a deep low over northeastern North Dakota. But if we switch over to the European model, very same time, it's going with a slower solution and further east. So Matthew's all the way down in the Bahamas. And there's no low in northeastern North Dakota. So a much different solution there. Now all of them are going with sort of an outbreak of, weak outbreak of cool air into the southern plains. But the timing differs quite a bit with all the models. There's the Canadian model going for stronger low development in Manitoba. Going with faster tracking on Matthew right there. It's got it all the way to the California coast. And then we look at the UK Met model going slower off the coast of Miami. And the low pressure centers are more in line with the European model. And then the last model that we'll look at is the JMA. This is the Japanese model. Going even slower with that hurricane. And the deeper isobars here suggest that that's a vortex that they dropped into the model right there. So they've probably got some sophisticated tropical storm handling on that model. Otherwise, most of the output looks pretty similar to the European model across the central U.S. But you can see the difference in the colors between the northern plains and the southern plains. That's that front dropping south. Now, we did have something come up a few days ago about what we were looking at. I was trying to figure out if we were looking at colors for thickness or if we were looking at these white lines here. I did some digging around and I found the thickness is actually these white lines here. It's not the colors. The colors depict height. And that really sucks because I like to feel it's looking the other way when I look at thickness. But the patterns are going to be overall kind of similar, so I can look at this and pretty much tell you that the front is going to be somewhere down here. But if we want to look at thickness like in real detail for these weathercasts, I'll probably end up picking another site like the GFS where you can really see them here. My pen doesn't want to cooperate. But I guess that's okay. I think we're probably on our last chart there. Okay, so that's all I've got for today. I appreciate all you guys watching. We'll be doing this again at 8 o'clock tomorrow and check in on Matthew and see what that's doing. So have a good evening. We'll see you then.